Good morning to all of you. Today we discuss distribution law. If you take two immiscible solvents A and B in a beaker, they form separate layers. When solute X, which is soluble in both solvents, is added, then solute gets distributed between two solvents A and B. The molecule of solute X pass from A to B and from B to A. Finally, a dynamic equilibrium is set up. In above figure shows the distribution of solute X between solvent A and B at equilibrium. The rate at which molecule of X pass from one solvent to other solvent is balanced, and concentration of X in solvent A divided by concentration of X in solvent B is equal to a constant. In 1891, Nernst gave an idea about the distribution of solute between two non-miscible solvents. This is called Nernst distribution law or distribution law or simply partition law. According to Nernst, if a solute X distributed between solute A and B at constant temperature and molecular condition of solute X is same in both the solvent, then concentration of X in A divided by concentration of X in B is equal to Kd. If C1 denotes the concentration of solute X in solvent A and C2 denotes the concentration of solute X in solvent B, then we can write C1 by C2 is equal to Kd. The constant Kd is called distribution coefficient or partition coefficient or distribution ratio. There, there is a relation between distribution law and solubilities. When a solute is shaken with two non-miscible solvents at equilibrium, both solvents are saturated with solute. Therefore, solubility also. Hence, we can write distribution law C1 by C2 is equal to S1 by S2 is equal to Kd, where S1 and S2 are the solubilities of solute in both the solvents. According to Nernst, when the distribution of solute X between solvent A and B has reached to equilibrium, the rate R1 at which molecules of X pass from A to B proportional to its concentration C1 in solvent A. Similarly, the rate R2 at which molecules of X pass from B to A directly proportional to its concentration C2. At equilibrium, R1 is equal to R2. R1 is proportional to C1, R1 is equal to K1 C1. Similarly, R2 is equal to KC2, where K1 and K2 are the constant. At equilibrium, R1 is equal to R2. Finally, we can write C1 by C2 is equal to Kd. This is the Nernst distribution law, where K1 and K2 are the constant at same temperature and Kd is the distribution coefficient. Now, there are some limitations of Nernst distribution law. One of the limitations is constant temperature. Temperature is kept constant throughout the experiment. Second limitation, molecular state of solute is same in two solvent. The law does not hold if there is association or dissociation of solute in one of the solvent. Another limitation, the law does not hold only when the concentrations are high. Therefore, it is applicable to only dilute solution. Last limitation, the concentration of solute are noted after equilibrium has been established.